Do 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 Science in pajamas, science in pajamas time. Alright, you guys, welcome back. Today we are going to talk about and introduce motion in 2 dimensions. Sorry about that. Alright, so first thing we're going to talk about is our 2 terms, which are scalar and vectors. So we have scalar versus vectors. Now these are 2 very important terms when we talk about motion. They do mean slightly different things. A scalar quantity only has magnitude, whereas a vector quantity has magnitude and direction. So that's the difference between these 2. So some examples of each would be distance is a scalar quantity because we only talk about the amount. Speed, that's kind of light, isn't it? Let's get something a little bit darker. So distance is scalar because it only talks about the amount. Speed is scalar because, again, it only talks about the amount. On the other hand, though, anything that is magnitude with direction would be a vector. So that includes displacement, it includes stupid lights. There we go. It includes velocity. It includes acceleration. Now, of course, there are more things that fall underneath these 2 categories, but these were the ones that we've been talking about so far and the ones we're going to keep looking at. So that's why we want to start with those. Alright, so we know what motion is. Motion is when an object changes positions. So if I have a cute little bug and it started out here and it ended up, so that's its initial location, and its final position is here. How did that happen? Well, that had to happen because something had to move. Whether the bug moved from here to there, or if the board moved and that made it appear as if the bug moved, something had to move for the bug to change position. So that's what we're looking at for motion. Now, previously, we've only been looking at motion in one direction. So we've been looking at it in terms of side to side, as well as up and down. Now, we've assigned positive and negative signs to these in order to show direction. So to the right would be positive, and opposite of right would be left, so left would be negative. Up would be a positive, and what's opposite of up? Down, which would be a negative. The negative sign has nothing to do with the value. It's not like in math class where a negative means less than 0. What it simply means is a direction. What happens though if we look at motions that are in 2 dimensions? So what if it starts off going one way and then ends up somewhere else? So in the case of the bug, it just shifted position to the right. But what if it moved at a diagonal? How do we figure that one out? You can't just add them up in order to figure out the displacement like we did before. So we have to do some new things. We have to consider angles at this point. Now this is where trig comes in handy. Some of you, if you've taken trigonometry already, might remember something called SOHCAHTOA. So these are to help with understanding the 3 trigonometry functions related to right triangles. So again, if we had our bug, and you move from here over to here, that means that he didn't just go in, he moved in a straight line, but to get from here to here, he had to move to the right some amount and move up some amount. And we have to look at these x and y components in order to figure out what the resultant would be, the displacement in this case. Now let's go back to the trig and talk about what this means, how it works, and how it relates. I'm going to draw this nice right triangle, more or less. You might remember that a right triangle, I know mine is not perfect, but let's pretend, has a 90-degree angle. Now this is a hypotenuse. This would be considered the opposite side. And this would be considered the adjacent side. Because what we're talking about is in relation to this angle right here. Now that circle with a line through it, that's theta. It's a Greek letter and it's oftentimes used to refer to angles. So this side, the vertical side, is opposite of theta. The horizontal side is adjacent to theta. So that's how they get their names. Now how does this relate to SOHCAHTOA and what does that mean? Well, the 3 main trigonometry functions that we're going to look at are sine, cosine, and tangent. So sine, cosine, and tangent. Now, how this is talking about in terms of, well, okay, what about OH, AH, OA? Well, don't worry, we're going to get there. So sine of the angle, so sine theta, is equal to opposite over hypotenuse. So opposite over hypotenuse, SOH. So cosine of the angle theta is equal to adjacent over hypotenuse. So CAH, ka. And tangent of theta is equal to opposite over adjacent, TOA, TOA. So that's just to kind of help us figure out what's related to what. Now the reason why this is important is because, remember, we're using this in regards to figure out the displacement of our cute little buggy friend. He didn't just move in one direction of motion, he moved in two directions of motion. So even though you move from here to here along that straight line path, which is our displacement, we're going to give it the, in terms of solving, we're going to give it R for resultant, because that's a lot of times what we'll call it. So the resultant is also the hypotenuse. To get from there to there, he had to move so much to the right, which would be our x value, if we're thinking about it like a graph, and so much up, which would be the y value. So therefore, how we can think about this is, if we think about, let me get rid of these for a moment. Yeah. So sine theta equals opposite over hypotenuse. All right, well, what if I know the resultant, but I want to find the y component? Well, we rearrange. We multiply both sides by the hypotenuse, and that would give us opposite equals hypotenuse times sine theta. So if I know the angle and I know the resultant, I can figure out the length of this side. So how much was the vertical displacement? You can also think of that as y equals r times sine theta. Because y is the vertical displacement, r is the resultant. Well, very similar to this, what if we want to look at and figure out the horizontal displacement? Remember, that was cosine theta equals adjacent over hypotenuse. Well, to find the x displacement, so the horizontal displacement, that means we want to solve for the adjacent value, which is also the x. To do that, we multiply both sides by the hypotenuse, and we end up getting adjacent equals hypotenuse times cosine of theta. Or we can rewrite that as the horizontal displacement, the x value, is equal to the resultant times cosine theta. All right. Well, what if we know x and y, but we don't know the hypotenuse and we don't know theta? So we know that the horizontal displacement was whatever that value is. We know what it is, and we know what the vertical displacement is. But I want to find out the resultant displacement, the actual displacement, and I want to figure out at what angle, because remember, displacement is a vector, so it requires direction. Well, if we're going to do that, the nice thing about finding the resultant, it's actually pretty easy if you know x and y, because you can use good old Pythagorean theorem for that. Pythagorean, I think I spelled that right, theorem. And what this says is a squared plus b squared equals c squared. Now we can think of that as the x value plus the y value equals the r value. All of that being squared, of course. So x squared plus y squared equals equals r squared. So take square root of both sides, and we get the resultant equals square root of x squared plus y squared. Too bad. And to find the angle theta, we can actually go and use the tangent. Because we know tangent of theta equals opposite over adjacent. Now, we want to get theta by itself, and how you do that is you take the inverse of tangent to both sides. So theta would equal the inverse tangent of opposite over adjacent, or in other words, theta would equal inverse tangent y over x. Rise over run, pretty much. And that will give you that angle. Alright. I hope that helps. We'll do some more videos later on today, but in the meantime, I hope this kind of helps you understand the basics of how we're going to go about solving these equations. But it's just a nice little intro, and in the meantime, you guys, stay awesome. Alright, take care. Bye-bye.